Now we're going to talk about multimode fibers and data centers. Here I want to guide you through the latest development in this field also, because we've been discussing a lot about fiber to the home, fiber to the X, and all the time it was implying, and it was basically single mode fibers, and we discussed this morning the band insensitive, everything with single mode. Here I want to review with you what really happened in the field of multimode. Multimode, basically, those fibers have larger core, typically 50 microns for the high capacity fibers, or 62.5 for some legacy OM1. But what's important to see, and here I'm taking a study that's published on a quarterly basis in the US by a guy named Matthew Burrows. He's just collecting from the industry in the US all the production and sales figures, and then circulate it to all the respondents. That's basically ourselves and the others. So you see the evolution in percentages, OM1 decreasing, OM2 decreasing, OM3 and OM4. And basically, the higher the number, OM3 is bigger bandwidth than and OM4 is bigger bandwidth. The higher number, the bigger the bandwidth. You see, for instance, 2010, so not so long ago, OM4 were only 9% of the overall consumption of the market for multimode. And multimode is very interesting because all the time we figure out, okay, multimode is kind of on the decreasing shape, and it's going to be replaced more and more by single mode, so not used anymore. But that's not the case. What's happening is that the technology has evolved in fiber. Multimode are capable of more and more bandwidth, and they still have this benefit of easier connectivity because of their big core. Really this capability to be connected to off-the-shelf lasers, VCSEL lasers, and really reducing the connection, the overall end-to-end cost. So that's why we've been pushed to develop more bandwidth fiber. And you see now the OM4 really amounts to close to 30% of the market in the US. At the scale of the world, this is, here I'm taking another analysis, CRU, and you see the trend is the same. The figures are a bit less because US is a bit ahead in terms of data center constructions with the monstrous Google, Amazon. They are just creating enormous data centers. And, but you can see that the consumption of OM4 is also increasing a lot in other regions of the world. So who are we in this domain? We are really number one in multimode. And it's not by at random that we are number one. We used to have 23% of the market. We now are close to 28%, 1/3 of the market, just because our production process, one of our production processes, because I told you through our history, we have access to many, many different production processes, but one is called the plasma-activated chemical vapor deposition. Anyway, forget about the name. What you have to keep in mind is that it's a process that is extremely precise and really enables to deposit layers of glass that are very, very thin and very precise. So, in fact, we have this tube of glass. Inside, we inject the gases, and we create inside, through a resonator here, we create inside a plasma. That is to say, we transform the gas, we excite the gases, transform them into this plasma, and almost all the gases are transferred in layers of glass. So at the same time, the others are producing the preform and depositing something like 50 layers, we are depositing thousands of layers. So it really makes multimode, again, from the start point to the end point. You want all your modes to arrive at the same time, just not to distort the information and keep the bit error rate at the good level. And to do so, you need to have some central mode going. Central mode are making a bit less distance, so you want them to go slower. and outer mode, they make more distance, so you want them to go faster. And then there is a typical shape that is a parabolic shape for the index profile. It's not the step index like core high index and cladding low index of single mode. It's a very engineered shape that we are able to design. We know if we want to target a given bandwidth, we need to design a given shape, and we can realize, really make that shape extremely precisely with our production process. It's like pixels in an image. The higher the number of pixels, the more precise the image is. This is exactly the same here. We have so many layers that we can produce exactly the targeted profile, and we can really equip our fibers with extremely high bandwidth. And for the others, okay, they have less layers, so it's a bit more shaky and tricky to realize high bandwidth fibers. So with this extraordinary growth of high bandwidth fibers and the flexibility of our process, this is the reason why we are really in the leadership role for those high bandwidth fibers. But again, high bandwidth is not enough, because data centers are evolving to more and more links, more and more cabling, patching, and inside each cable, you will see with Matteo afterwards, more and more fibers, because to make 100 gig links, for instance, you have 10 fibers transmitting, 10 fibers receiving, so you need to have all those fibers in the same cable. So the cables are getting denser and denser, and the links, the number of links, the patching is getting also denser and denser. So the request we've been having, and especially was around 2010, was, okay, high bandwidth, super, keep it, but make it also band insensitive. Okay, so exactly the same as for single mode. And please make it band insensitive, but make it also that I can patch it, connect it, splice it to the legacy infrastructure I'm already having in my data center. So again, make everything the same, but higher bandwidth and better banding performance. This is something we managed to do. It's not straightforward, but we managed to do, also applying the same trench concept around our core and equipping the fiber with band insensitive characteristics. In multi-mode, it's a bit different, because if you look at the mode, the central mode, it's intrinsically band insensitive. So means under pressure and under band, it stays in the core. But the higher order modes, the ones that are really at the limit, when you bend the fiber, those are the ones exiting the fiber. And by putting some trench here, you really improve the performance for those higher order modes that are also kept in the core. So that's what we did. And now, when I presented you the OM4 Pi, most of the OM4 that we sell, in some countries, basically 100% of OM4 is band insensitive. In some cases, people don't request, but most of the case, if you can get everything for the same price, why would you compromise on the fact your fiber is band insensitive? So this is a table, I'll not get through it, but basically you have different speeds for Ethernet or storage, I mean fiber channel. 1 gig, 100 gig Ethernet, now the latest generations. And of course, over different grades of fibers, you can make a given distance. And typically, on OM4, you can make 150 meters at 100 gig Ethernet, so interconnection in data centers. And we even defined ourselves some premium grade, like OM4 Plus, where we can move up to 200 meters. And we also, it's not here, but we also developed recently another multimode fiber. Okay, multimode is transmitting many modes, but people are considering to increase density of cabling to transmit bidirectional on one fiber. This is called BiDi, and it's a new technology that is coming in, and basically using several modes on one wavelength, 850 nanometer on one direction, and several modes on another wavelength, 913 for the other direction. So we also developed a fiber that is multimode, high bandwidth, bend insensitive, and capable of multiple wavelengths. So you see, the world of multimode is evolving a lot. We are really a leader in the driver's seat in this domain, and we can, again, same as for single mode, use this latest technology in our cabling facilities that Matteo will guide you through now.
Thank you, Alain. So basically, Alain explained quite well, I would say, why our fiber is the best. And since we are the largest cable manufacturer in the world, and we are quite good at putting our best fiber in the cables, we can offer to you the best cables for the Datacentre Solutions. We cooperate with many other companies around the world. We sell them fibers, cables, and connectors. For example, this offer here is this is a range of product that comes from Ortronics, which is a division of Legrand that deals with data centers. And they just buy their cables from us, and they put it in a package, which is the part that gets to the customer. In terms of data center, when you build a data center, it's not easy at all, because one of the problems that you run into is the fact that all these active equipments, which are around here, needs to be cooled down. Otherwise, they don't work properly, and the consumption of power is even higher. So it's extremely important that when you design a data center, you take into consideration the cooling. So the first part of the build of a data center is thinking how you can make it the most effective. And this is something that is part of the offer of any constructor of data centers. In particular, here we can see part of the offer of Ortronics. As you can see, you have LC simplex or duplex connector, or you can have MPO connectors, which are made by us, by the way. So the typical use of an MPO connector for a 40 gigabit per second transmission is you have 4 fibers out of 12 which are used for transmission. 4 fibers are used for receiving, and then you have 4 spare fibers that currently are not used. But when you want to go up to 100 gigs per second, you use 2 different connectors usually, and you have 10 fibers which are used and 2 spare. One, again, is for transmission, and the other one is for receiving. But you can have them both in one single connector. And this is where it's extremely important having Prysmian Draca fibers in your cables, because we can give you very small and compact cables which matches perfectly with this kind of connector. Let me show you. This is, for example, a small ribbon cable which has 12 fibers, and it's flat, and this kind of configuration, it's 0.3 millimeters by 3.1 millimeters, so it's incredible. Matches perfectly over an MPO connector with just 10, let's say 12 fibers inside. Okay, this is not probably a configuration that you would like to use everywhere, because it's actually quite flat. Or there is Kevlar as well, just to protect, give a little bit more strength to the cable. I was saying, you can't use a flat cable everywhere, because you can bend it just in one direction, and you can't bend it in both directions. So you can actually have the same 3 millimeters, 12 fibers again. And this is the structure of the cable. The yellow hexagons here represent the aramid. And so you have fibers, aramid, and the protection. You can't do that if you don't have bending sensitive fiber. And you can't get a cable of 3 millimeters without bending sensitive fiber, or without Draca fiber. Same you can do with 2 bundles of fibers for the double stack connector, the MPO connector with 24 fibers. And you can have, again, a cable of 3.6 millimeters, which is very bendable because it's round, and it's very resistant. And the fibers inside are so compact and so in such a small place that you couldn't do that if you didn't have bending sensitive fibers. Again, the configurations of the cables is absolutely, we can offer to you whatever you want. This is, for example, a shotgun or figure of 8 cable. So you will have one connector on one of the 2 tubes and another connector on the second tube, if you don't want to use the double stack connector. Or again, somebody asked me in the morning regarding a bundle of cables. Yeah, this is basically a flex tube made with multi-mode fibers. We can go from 24 up to 144 fibers, and the diameter will be 9 millimeters, which is amazing. And you can do that, this kind of configuration, just using our fibers. The last slide that I'm going to show you, imagine that all of these are units of 3 millimeters. Then you want to have a cable which is more ruggedized, and you put a strand member in the middle. And again, very compact cable, very, very compact cable. And you can't do that if you don't use bending sensitive fibers and have the advantages of the trench assisted technology. Okay, so in terms of data centers, that's all. If you have any question, I'm happy to answer. And in case, you will have my details and you can send me an email.